Okay, so square roots of variable expressions. This is just building upon what we learned yesterday, where we're simplifying square roots, rational roots as well as irrational roots. It's just that now we're also going to see variables inside the radical. So there's a little trick to simplifying these as well. Other than that, it's really just the same as what we were doing yesterday. So just think of it as yesterday's content with one additional step. Now, we'll start with some simple ones here because these numbers, 196, 36, and 64, all just happen to be perfect squares. But it'll help us illustrate the point about how to deal with variables. So I'm taking the square root of 196y squared. And there's two factors here to consider. One is the 196 and the other is the y squared. Now, the square root of 196 is just 14. So that comes out of the radical as just 14. 14 squared is 196. Now, you may be able to figure this one out in your head. What's the square root of y squared? In other words, what do I multiply by itself to get me y squared and then just work it backwards? Well, the answer there is just y. Y times y is y squared. So all you have to do is cut the exponent in half. This is y squared. This is y to the first. So our answer is just 14y. And there's nothing left inside the radical for this one. Now, apply that same logic to the next one here. The square root of 36x to the 8th. Well, the square root of 36 is just 6, so that comes out of the radical. And then again, it's the same logic here. What variable, what exponent has to be squared in order to get 8? Well, in this case, it's going to be x to the 4th. Because if you think about it over here, well, if I take x to the 4th and square it, right? X to the 4th times x to the 4th gives me x to the 8th. That's just using our exponent rules, right? So anytime I multiply two like bases, we add the exponent. That's how we get x to the 8th. That's why you see x to the 4th here. So the square root of x to the 8th is just x to the 4th. Another way of thinking about it is, okay, if I take x to the 4th and square it, well, now I'm raising an exponent to another exponent, so I'm multiplying the exponents. Whatever way you want to think about it, you're still going to get x to the 8th. The shortcut, though, for these type of problems, when we're working with radical expressions, the trick here is just to cut the exponent in half. That's all you have to do. So this last one here, go ahead and try this one on your own. What's root 64 m to the 10th n squared going to give us? Well, again, this one, there's not going to be anything left inside the radical. These are all perfect squares. The square root itself is going to disappear, and that's just going to give us 8 m to the 5th n. And if you wanted to test it, right, this is your answer, but if you wanted to sort of prove it, you could also just take this and square it, right? I could redo this or undo it. I could say 8m to the 5th times n times 8m to the 5th times n. And what's going to happen here? Well, 8 times 8 gives us the 64. M to the 5th times m to the 5th, there's your n to the 10th. And then finally, n times n gets you the n squared. So you see the connection there. Now, the last thing I want you to see with this is, we'll just do one of these for now, is that sometimes the numbers won't be perfect squares, and the variables will have exponents that aren't even. So how do we simplify that? Well, it's going to be similar to the problems that we saw yesterday. So first I'm going to try and take this 18. I'm going to ignore the variable for just a second. Let's just deal with the square root of 18, right? Well, let's try and factor that into a perfect square here, right? So what factor of 18 is a perfect square? Well, that's going to be 9, right? Because 2 times 9. So we can write this as 2 times 9 times a to the 3rd. And we'll just leave that a to the 3rd alone for now. Okay, so now we'll simplify that a little bit further. 9's a perfect square, so I'm going to take the square root of 9, take it out of the radical, and write that as 3. So now I have 3 root 2 times a to the 3rd power. Now remember, I can only cut this in half if I have an even numbered exponent. So it might be helpful to write this as just 3 powers of a times a times a. I'm just writing this without the exponent. Remember, whenever we see 2 of something, right, that's a perfect squared. Here's our a squared. Right? So if I have an a squared inside the radical, I can take that out of the radical and rewrite it as just 3a. So I took the square root of a squared, take it out, put it next to the 3, so now we have 3a. And then what's left inside the radical? Well, that's just 2a. I still have the 2. I still have the a in here. There's nothing I can do with this, though, because 2 is not a perfect squared, and a to the first is there's no perfect square there either. So your answer for this one is just 3a root 2a.